All right, you may have seen this before. Take a little water, put it on my board with the strings, and then let it go. Stays on real nice, no glue. I can go slow too, but how slow can I go? Let's use the more traditional bucket of water trick. We'll measure from my shoulder to the bottom of the bucket. It's a little more than a meter. The water's not going to come out as long as the centripetal acceleration is greater than 9.8. I'm going to go slower. I can hear it slosh. See if you can estimate the velocity at the top. That's about as slow as I can go at the top, and then it starts to come out. Now, if you're wondering about how all that works, gravity is always going to pull down. If the bucket is going down at the same rate as the water won't come out. It'll be in free fall. The water and the bucket are falling at the same rate. If I do it upside down, as long as the acceleration downward of the bucket is the same as the water can't come out. If I go upside down too slow, the water will come out. So here's my bucket of water. The question is, how slow can I go? From my shoulder to the water was about 1.1 meters. Well, let's draw a free body diagram just for the water. You got gravity pulling the water down, and you've got the normal force from the bottom of the bucket pushing the water down as well. They're both pointing towards the center of the circle. So what's producing the centripetal force? Both of them are. Now, whether I go fast or slow, gravity is still going to do its thing. But the faster I go, the bigger that normal force is. I'll have to pull harder on the bucket to keep it in the turn if it's going fast. But I want to go slow. So the slower I go, the weaker the Fn becomes until it's zero. Then we can say mv squared over r equals mg. Gravity is the only thing producing the centripetal force. Of course, the mass cancels, and the minimum velocity at the very top would be equal to the square root of rg. You can watch the video and see how close I am. You can use my arm for a scale sideways to see how far I go at the top. The reason why you can't really do a full circle is because gravity is going to pull it down, making it go faster. Now, I know right now in this unit, we've been saying the velocity is the same at the top and the bottom, but remember, that's just an approximation. You can watch the video and you'll see how I go faster down below. You can't do anything to stop that. Gravity is going to keep making it go faster. We'll worry about that in another chapter. So just to summarize, gravity will accelerate the water down at 9.8. If the bucket moves in a curve with a velocity equal to the square root of rg, there'll be a centripetal acceleration of the bucket in the same direction as gravity at the top. The bucket falls at 9.8, gravity's pulling down at 9.8, and the water can't come out of the bucket. Just to prove it, okay, go get your own bucket and give this a go. I want to see you do it at home with your family.